Welcome, curious dreamer, to the Midnight Scientists. You have navigated the currents of your day, perhaps a long and demanding one, and now you have arrived. You have arrived at this quiet harbor, a place to anchor your thoughts, to allow the gentle tide of relaxation to pull you softly away from the shore of your waking concerns. It is time to unwind, time to slow the rhythm of your breath, to feel the weight of your body as a comforting presence, grounding you in this moment of peace. It is time to drift off to a quieter place. Tonight, our vessel of dreams will take a slow and gentle journey into one of the most serene and misunderstood wonders of the cosmos, the black hole. But let us leave behind the images from our fictions and films. The black holes we will visit tonight are not the loud, dramatic monsters of story. There will be no roaring voids or cosmic whirlpools. No, the black holes we are meeting tonight are the real ones. They are calm, ancient, and possess a profound, quiet stillness. They are astonishingly well behaved for something that so gently, so completely, bends the fabric of space and time. As you settle in now, feel the space you occupy. Perhaps you are wrapped in the soft embrace of a blanket, a gentle weight that reminds you of your safety and comfort. Perhaps you are listening with your eyes already closed, the darkness behind your eyelids a welcoming canvas for our journey. Wherever you are, on a couch, in your bed, or simply floating in your own quiet corner of the universe, take a moment to be present there. I often wonder where our sleepy ship sails each night. It's a lovely thought, to imagine this quiet broadcast reaching across the globe, a thread of stillness connecting us all. Perhaps it is late night where you are, the moon high in the sky, or maybe it is the early hours of a new day, the world still hushed and asleep. If you feel a gentle impulse, you might imagine sending a thought out into the comments, a quiet signal of your time and place. It is a comfort to know how far these sleepy stories travel, and as we prepare to drift toward the soft edge of slumber, a kind and gentle reminder. If these nighttime voyages bring you a measure of peace, a quiet tap of the like button, or a soft click to subscribe, helps our channel float a little further into the digital sea. Think of it as adding a faint, distant star to our sky. It is a silent, supportive gesture, and it is deeply appreciated. But do not trouble yourself now. Your rest is all that matters. I will do my best not to make our journey too interesting. But if, by some chance, the profound mystery of black holes happens to keep your mind gently curious for a little while longer, then I hope you will learn something truly cosmic as you drift away. So now, let us begin. Take a slow, deep breath in, feeling your lungs expand like the quiet unfolding of a nebula. And now, a long, soft exhale, letting it all go. Let the stars above you, imagined or real, and the gentle science around you, lull your mind into a profound and peaceful stillness. Our story begins, as all stories of black holes do, in the deep and silent dark. Imagine, if you will, a place in the universe where the laws of physics become soft and pliable, where they seem to bend and wobble, and generally behave as if they too have had a very long day, and now wish only to rest. This is the realm of the black hole, a place where light itself, the fastest thing we know, the tireless messenger of the cosmos, finally ceases its journey. It is caught, not in a violent trap, but in a place of such immense gravity that all paths lead inward, to a place of ultimate rest. But what are they, truly? Not swirling portals to oblivion, but something far more subtle, more fundamental, and dare I say, more peaceful. At its very heart, A black hole is a region of space where gravity has achieved a perfect, quiet victory. Everything in the universe is a gentle dance between outward pushing energy and inward pulling gravity. In a star, the fiery furnace of nuclear fusion creates light and heat that push outward, holding the star up. At the same time, the star's own immense mass pulls everything inward with the silent, persistent force of gravity. But when a truly massive star exhausts its fuel, the fire at its heart grows dim, the fusion stops, the outward pressure fades away like a final soft breath, and gravity, patient and unopposed, finally wins. The star begins to collapse in on itself, folding inward tighter and tighter, until all of its magnificent fiery self becomes something impossibly dense and unimaginably small. This final point of rest is called a singularity, and it is wrapped in a gentle cloak of no return, an invisible boundary known as the event horizon. Let us linger on these ideas for a moment. The singularity, it is a difficult concept, so let us not think of it with jarring words like infinite density. Instead, let us imagine all the matter of a colossal star, a sun many times larger than our own being, carefully folded like a precious piece of paper into a space smaller than a single grain of sand. It is the universe's ultimate act of compression, a final, quiet state of being. And around this point of quiet singularity lies the event horizon. This is not a hard surface. You could not stand on it. It is more like the shore of a perfectly calm, dark ocean, an invisible line. Before you cross it, you could, with enough effort, turn and sail away. But once you drift past that shore, all currents flow in one direction. There is no turning back, not because of a great force, but because space itself is flowing inward, carrying everything with it gently and inexorably. Light matter, even our imaginary ship, all would drift toward the center, not with a crash, but with a silent final merging. Now, here is a wonderfully calming thought. Black holes are in fact among the simplest objects in the entire universe. According to our understanding, a black hole, no matter how complex the star that formed it, can be described by just three properties: its mass, how much it weighs; its spin, how fast it turns; and its electric charge. That is all. Imagine everything that fell in: a star, a planet, a cloud of cosmic dust, with all its history and complexity, is smoothed away, its essence reduced to just those three simple qualities. There is a name for this beautiful simplicity: the no-hair theorem. It suggests that black holes are cosmically smooth, free of complicated features. They are a state of profound simplicity. This idea of lost information once troubled scientists, leading to great debates. But for our journey tonight, let us not worry about paradoxes. Let us simply embrace the idea that in their simplicity, black holes offer a kind of peace, a release from complexity. And despite their dramatic origins, black holes are not cosmic vacuum cleaners. They do not roam the galaxy, seeking things to devour. They are passive. They are still. If by some impossible magic we were to replace our sun with a black hole of the very same mass, something remarkable would happen. Nothing. The Earth, the other planets, we would all continue in our orbits, exactly as we do now. It would become very dark, and very cold, of course, but the gravitational dance would remain unchanged. Black holes do not suck. They simply sit, quietly and profoundly, curving the space around them with their presence, and that is how we find them. Not by seeing them, for they are the color of the space they inhabit, but by observing their influence. We see a star wobbling in its path, pulled by an invisible dance partner, and we know, We see gas from a nearby star being gently pulled away, spiraling into a glowing halo of warmth and light before it disappears, and we know the quiet giant has stirred briefly for a meal, but for the most part, black holes do very little. They emit no light, they make no sound, they pose no threat unless you were to travel for thousands of years to get extremely impossibly close. The nearest known black hole is over 1,000 light-years away. To worry about it would be like worrying about a single grain of sand on a distant continent. Because they are so perfectly dark, it was long thought we would never see one. But in 2019, through the combined effort of telescopes across the entire planet, we did. We saw the shadow of a black hole. A collaboration called the Event Horizon Telescope captured the silhouette of the supermassive black hole at the heart of the M87 galaxy, 55 million light-years from here. And what did it look like? Not a gaping maw of doom. It looked like a soft, glowing ring of light, a halo of warm gold and orange, surrounding a perfect circle of peaceful darkness. It was dignified, serene. There is something deeply comforting in the idea of something so immensely powerful being so incredibly calm. In a universe filled with exploding stars, chaotic galaxies, and cosmic collisions, the black holes are the quiet ones. They are the introverts of the cosmos. They do not seek the spotlight. They simply sit at the crossroads of gravity and geometry, being themselves. They follow the rules of physics with a quiet precision. It is like discovering that the universe's most powerful entities are also its most orderly librarians, whispering as they file everything away into a state of perfect stillness. So as you drift deeper now, let your idea of a black hole soften. Do not picture a violent devourer. Picture a quiet ripple in the fabric of space, a place where time itself slows down, where light comes to rest, and where matter finds its final silent home. They may be the end point for stars, but they are far from chaotic. In fact, they may be the most peaceful residents of our entire cosmic neighborhood. They don't scream for attention. They don't sparkle. They simply exist, calmly, eternally. Let us now imagine a star, a truly colossal star, not our modest middle-aged sun, but a giant 10 or perhaps 20 times more massive. It shines with a brilliant blue-white light, burning hotter and living faster than 1,000 lesser suns. These are the rock stars of the cosmos, loud, brilliant, and destined for a truly spectacular farewell. This is the cradle where a black hole is born. You see, the life of a star is a constant, delicate balancing act. Deep in its core, the crushing pressure of gravity fuses atoms together, turning hydrogen into helium and releasing a tremendous flood of energy. This energy pushes outward, a constant radiant pressure that holds the star up, preventing it from collapsing under its own immense weight. It is a perfect equilibrium. The outward force of fusion and the inward pull of gravity, held in a cosmic standoff for millions of years. But nothing, not even a star, has an infinite supply of fuel. Eventually, the massive star burns through its hydrogen, then its helium, then carbon, moving on to heavier and heavier elements. A desperate sequence of burning to keep the light on. But this journey has a final destination: iron. Creating iron through fusion does not release energy, it consumes it. The furnace at the heart of the star, which has raged for millions of years, suddenly goes cold. The outward push, the force that held back gravity for an entire lifetime, vanishes in an instant. Now, gravity is unopposed. Imagine the weight of 20 suns, with nothing to hold it up. The core of the star collapses. In less than a second, A region the size of the Earth is crushed down to the size of a city, and then smaller still. The outer layers of the star, now unsupported, begin to fall inward, crashing down onto the collapsed core. This catastrophic infall can trigger a titanic rebound, an explosion of unimaginable power that blasts the star's outer layers into space. This is a supernova. For a few weeks, it will shine with the light of 100 billion suns, brighter than its entire home galaxy. It scatters the heavy elements it forged in its heart. The carbon, the oxygen, the iron across space. These stellar ashes will one day form new stars, new planets, and perhaps even new life. The iron in your blood, the calcium in your bones, it was all forged in the heart of a dying star, and scattered by an explosion like this one. You are, in the most literal sense, made of stardust, a poetic legacy from a star's final brilliant act. But what of the core that remains? After the glorious explosion fades, what is left behind? If the remnant is not too massive, it can settle into a quiet retirement as a white dwarf, a hot, dense ember the size of a planet that will spend trillions of years slowly cooling into blackness. If it's a bit more massive, it becomes a neutron star, an object so dense that a single teaspoon of it would weigh more than all mountains on Earth. But if the mass of the dying star's core is more than about 3 times the mass of our sun, gravity is overwhelmed. No force known to physics can stop the collapse. Not the pressure of electrons, not the pressure of neutrons packed together. The core continues to collapse past the point of being a neutron star, past any point we can truly describe. It simply folds in on itself until it becomes a singularity, a point of quiet finality, and in that moment of profound silent surrender, a black hole is born. No flash of light marks its creation, no sound. One moment, there was the heart of a star. The next, there is only a shadow, a perfect absence wrapped in space-time. This is a stellar mass black hole. They are the most scattered throughout our galaxy, like cosmic fossils, the quiet remnants of stars that lived fast and died brilliantly. We cannot see them, but we can feel their presence. We see them in binary systems, where they gently siphon gas from a companion star. This gas doesn't fall straight in. It spirals, forming a luminous accretion disk, like water swirling around a drain. This disk heats up to millions of degrees, glowing brightly, not with visible light, but with X-rays. And it is this glowing, spiraling gas, the black hole's dinner, that reveals the dark companion it orbits. Some of these stellar mass black holes, however, are utterly alone. They have no companion to feed on. They drift through vast dark spaces between the stars in near total silence and invisibility. These are the rogue black holes, the true hermits of the cosmos. We can only find them by chance if one happens to pass directly in front of a distant star. Its gravity will bend the starlight from behind it, causing the star to briefly brighten and warp in a way that only a massive invisible object can. A tiny gravitational twinkle, betraying the presence of a silent wanderer. Let us just take a moment now to float in this idea of stillness. From the fiery, brilliant life of a massive star, from the unimaginable violence of a supernova, comes quiet, comes stability, comes a simple invisible object that will now drift peacefully for trillions upon trillions of years. It is a strange and beautiful transformation from a life of fiery drama to an eternal existence of serene silence. They are cosmic monks, having witnessed the heights of creation and chaos, now sitting in quiet contemplation for the rest of time. They are quite literally sleeping giants. Black holes have a formidable reputation. The name itself conjures images of bottomless pits, cosmic drains pulling in everything in their path. But let us take a slow, calming breath and set that reputation aside, because the truth, for the vast majority of black holes, is one of profound inactivity. Many, if not most, of the black holes in our universe are doing, quite literally, absolutely nothing. They are not feeding. They are not glowing. They are not shooting out jets of energy. Scientists call them quiescent, which is a beautiful and formal word for quiet. They are simply there, sitting peacefully in the dark, invisible, causing no fuss at all. You could fly a spaceship right past one at a safe distance, and if you weren't looking for the subtle warping of starlight, you would be none the wiser. No alarms would sound. No great force would pull at you. There would just be a quiet, unassuming pocket of immense gravity, minding its own eternal business. Perhaps it is helpful to think of them not as predators, but as deep, still lakes hidden within a vast forest. Immensely deep, yes, but entirely peaceful, unless something happens to fall in. A black hole will not chase you. It does not have a reach that extends indefinitely. Space is incredibly vast, and black holes are, by cosmic standards, incredibly small. Unless an object's path takes it very, very close, it will drift by completely unaffected. For a black hole to do anything noticeable, anything flashy, it needs fuel. It needs matter that it can draw in. But most of the universe is empty. Even in the dense center of a galaxy, the space between the stars is enormous. So, while a fortunate few black holes might find themselves next to a cosmic buffet, most are sitting in the quiet corners of the galaxy, with nothing to eat. They are fasting, and they are patient. When a black hole does find a snack, perhaps a stray cloud of interstellar gas drifts too close, it can awaken for a while. The material is caught by the black hole's gravity and begins its slow inward spiral. This is the accretion disk we spoke of, a hot glowing platter of material. But it is important to remember, this glowing disk is not inside the black hole. It is orbiting just outside the event horizon, that invisible shore. The light we see comes from the friction and compression of the gas itself, as it heats up before taking its final plunge. The black hole remains perfectly dark at the center of the glow. It is like seeing the warm steam rising from a cup of tea. The steam tells you the tea is hot, but the steam is not the tea itself. The glow tells us the black hole is there, but the glow is not the black hole itself. There are, of course, exceptions to this sleepy behavior. We will soon visit the supermassive black holes at the centers of galaxies, which can go through truly spectacular energetic phases. They can power quasars, blasting out jets of energy that dwarf the light of their entire galaxy. It is as if the sleeping giant stirs, has a moment of cosmic indigestion, and lets out a sigh of energy that stretches across the cosmos. But even this incredible activity is fleeting. In cosmic terms, it is a brief flash of brilliance. After a few million years, a mere blink of an eye for the universe, the fuel runs out, the jets fade away, and the black hole goes back to sleep. For the vast majority of their incredibly long lives, black holes are dark, quiet, and almost impossible to detect. We only know they are there through their gentle gravitational influence on the things we can see. When we see a star orbiting something invisible, and our calculations tell us that this invisible partner is incredibly massive and incredibly compact, we can be fairly certain we have found a sleeping black hole. This quiet nature makes them a source of gentle fascination. Trying to find a quiescent black hole is like trying to find a perfectly silent black cat in a pitch-dark room, using only your understanding of how its weight might affect the floorboards. And just like a cat, The black hole doesn't care if you are looking for it. It will continue to sit there, purring with gravity, whether you are watching or not. And they are not entirely black. In the 1970s, the physicist Stephen Hawking proposed that black holes must emit a faint glimmer of radiation, now called Hawking radiation. This is a tiny, subtle effect, born from the strange rules of quantum physics at the very edge of the event horizon. This means that black holes can, very, very slowly, lose mass and evaporate. But we must understand the timescale we are talking about. A black hole with the mass of our Sun would take an estimated 10 to the power of 67 years to evaporate. This number is so large it is functionally meaningless to the human mind. The current age of the entire universe, from the Big Bang until now, is about 13.8 billion years. It is a number that doesn't even make a dent in the lifespan of a black hole. So, if you are picturing a black hole as a terrifying, all-consuming force, it may be time to gently adjust that mental image. Think of it more like a lighthouse whose lamp has gone out, still standing, still solid, but not currently broadcasting its presence. Its existence gently shapes the space around it. A silent landmark of gravity, strong, silent, and incredibly stable. There is a deep peace in this stability. In a universe of constant change, the black hole endures. It is a quiet promise of stillness, a silent sentinel in the starry dark. We have been drifting among the quiet stellar mass black holes, the solitary ghosts of long-dead stars. But now, let us set a course for the center, toward the heart of the great spiral galaxy we call home. For here, in the downtown metropolis of the Milky Way, resides another class of black hole altogether. These are the giants, the supermassive black holes. And when we say supermassive, the word barely does them justice. These are titans ranging from millions to even billions of times the mass of our Sun. Imagine a black hole so vast that it could swallow our Sun and every other star you have ever seen in the night sky, and still have room for more. The one at the heart of our own Milky Way is named Sagittarius A, pronounced A star. It weighs about 4 million solar masses, and by the standards of the cosmos, it is a relatively modest one. Now, here is the most fascinating part. Despite this monstrous size, our entire galaxy orbits this giant in a state of perfect calm stability. There are no apocalyptic effects, no galactic panic. The billions of stars in the Milky Way, including our own Sun, swing in a slow, graceful dance around this central point. It is not a destroyer. It is an anchor, a cosmic keystone, holding the entire structure of our galaxy together. But how did they get so large? This is one of the quiet, lingering questions in astronomy. We understand how a single star collapses to form a stellar mass black hole, but no single star is massive enough to form a supermassive one. The theories are like gentle streams converging. In the early universe, large clouds of gas collapsed directly, forming seed black holes of thousands of solar masses. Or perhaps the first massive stars created the first black holes, and over the eons, these seeds began to grow. They would merge with other black holes, their event horizons combining like two soap bubbles becoming one. They would draw in the dense gas that was so common in the young universe, growing steadily over billions of years. But even this presents a puzzle. We have seen signs of enormous, billion solar mass black holes existing very early in the universe's history, when it was less than 1 billion years old. This is not much time for a black hole to grow so large. It's as if we found a giant, ancient tree in a forest that is itself very young. The story of their growth is a mystery we are still gently unraveling. Whatever their origin, once these giants settle into the centers of galaxies, they become the gravitational heart. They are like the quiet elders of the galaxy, stoic, enormous, and unmovable, and for most of their lives they are dormant, barely interacting with their surroundings. Our own Sagittarius A/S is by all accounts quite tame. It is not currently feeding on much. It is in a state of hibernation, but we see echoes of its more active past, like ghostly footprints. Giant bubbles of high-energy gamma rays extend above and below the plane of our galaxy, remnants of a feast that may have happened millions of years ago. To truly see this gentle giant, we needed the power of a telescope the size of our planet. In 2022, the Event Horizon Telescope collaboration released the very first image of Sagittarius A/S. It was not a photograph in the traditional sense, but a picture painted with radio waves, carefully reconstructed. And there it was, a soft, blurry ring of glowing gas, a halo of orange light, surrounding a perfect circle of darkness, the shadow of our galaxy's heart. It is not a wormhole from a movie. It is fuzzy. It is gentle, but it is real. It is the quiet confirmation that something vast, invisible, and powerful holds our galaxy in its gravitational embrace. And there is a quiet wonder in this. These black holes do not just reside in galaxies, they appear to shape them. The presence of a supermassive black hole seems to regulate the birth of stars, to conduct the flow of gas, to provide the architectural stability for the entire galactic structure. There seems to be a symbiotic relationship, a coevolution. The galaxy and its central black hole grow together, like a tree and the soil it is rooted in, each influencing the other over billions of years. It is not a dictatorship of gravity, but a quiet cosmic agreement. So while it might seem strange to describe a supermassive black hole as peaceful, in many ways, that is precisely what they are. Their presence brings order. Their gravity is a silent sculptor, holding together the stellar stage upon which the grand performance of our galaxy unfolds. They are not to be feared. They are to be respected, enigmatic engines of gravity, pulsing faintly at the very heart of creation. So the next time you look up at the night sky, and perhaps see the faint misty band of the Milky Way, remember that at its center, 26,000 light-years away, there is a sleeping giant, 4 million suns worth of mass, curled into a silent sphere, not tearing things apart, but simply resting, anchoring, waiting. Let us now drift closer. Let us imagine we are in a special vessel, one that can feel the subtle textures of space-time itself as we approach a sleeping, supermassive black hole. The universe begins to feel different, not violent, but strange and wonderfully slow. This is the effect of gravitational time dilation, a core prediction of Einstein's theory of relativity. The stronger the gravity, the slower time flows. Here, near the edge of this gentle giant, this effect is profound. If we were to hover here, just outside the event horizon, time for us would slow to a crawl compared to the rest of the universe. We could watch galaxies spin and stars age in what feels to us like mere moments. Hours for us could be centuries for everyone else. Allow yourself to feel this. Feel your breath slowing down, deeper and slower. Feel the rhythm of your heart becoming calm and steady. Imagine being in this place of profound temporal peace, a bubble of stillness where the frantic rush of the cosmos passes you by. It is a form of time travel, not into the past, but into a state of deep, deep rest. Now, imagine the black hole is spinning. Most of them do. They carry the angular momentum of the star that formed them. or the gas they have consumed. A spinning black hole does something remarkable. It drags the very fabric of space-time around with it. This effect is called frame dragging. In a region just outside the event horizon called the ergosphere, you could not stay still even if you wanted to. Space-time itself is in motion, like a slowly turning river. You would be invited, in a gentle cosmic waltz, forced to spin along with black hole, carried by the current of space-time itself. Not a violent whirlpool, but a graceful silent dance. And what of that final boundary, the event horizon? What happens if we were to drift across it? For a small stellar mass black hole, the experience would be disruptive. The difference in gravity between your head and your feet would become immense, stretching you apart in a process colorfully known as spaghettification. But here, at the edge of our supermassive giant, the story is very different. The event horizon is so vast, and so far from the central singularity, that the gravitational gradient is incredibly gentle. You could, in theory, drift across the event horizon without feeling anything at all. One moment you are outside, the next you are in. The boundary is invisible and intangible. You would simply float across, into the quiet darkness, your last moments perhaps being ones of eerie, absolute calm. The journey inward would be your final one, but it would be a peaceful one. Let us float back out now, away from that gentle shore. The area around a black hole is a realm of extraordinary physics. Yes, but it is not all chaos. In many ways, it is a cosmic ballet. Matter spinning, energy flowing, time stretching, and sometimes we can even hear its music. When two black holes, locked in a binary system, orbit one another, they stir the space-time around them. They create gravitational waves. As they spiral closer and closer over millions of years, this hum becomes stronger, until in their final moments of merging, they release a crescendo of gravitational energy. This is not a sound you would hear with your ears, but a vibration of space itself. First detected in 2015, it was as if we had learned to listen to the universe in a completely new language, a language of pure gravity, a language that tells us stories of the silent, dark dancers of the cosmos. It is a language of stillness and motion, of presence and absence. The silence of the black holes is full of these quiet stories. All you have to do is listen as you drift and dream. Black holes seem eternal. They are the ultimate endpoints, the most resilient structures in the cosmos. But is that truly the end of the story? Or can even these mighty invisible giants eventually meet their end? It turns out, they can. And their demise is as slow, as quiet, and as strange as their existence. It happens through that faint glimmer we spoke of earlier, Hawking radiation, that quantum whisper at the edge of the void. This process is unimaginably slow. The universe, at 13.8 billion years old, is still in its infancy. Stars are still shining brightly. This is the stelliferous era, the era of stars. But it will not last forever. In about 100 trillion years, the last star will flicker and die. The universe will go dark. All that will be left are the cooling embers of stars, white dwarfs, neutron stars, and the black holes. This will be the degenerate era, a universe of shadows and silence. But the black holes will persist. As everything else fades, they will become the last significant objects in the cosmos. And then, as the eons pile up into numbers too vast to name, they too will begin their slow fade. Through the steady, patient whisper of Hawking radiation, they will give back their mass, particle by particle, to the universe. A supermassive black hole might take a Google years. That is a 1 followed by 100 zeros, to evaporate completely. This is the black hole era, a time when black holes are the only active things left, the last faint night lights in an otherwise cold, dark, and empty cosmos. Their final moments will not be an explosion. There will be no grand finale. The end of a black hole is more like a final gentle sigh, a slow exhale of all the matter and energy it has held in its quiet embrace for trillions of years. And once the very last black hole has whispered its last particle of radiation into the void, the universe will achieve its final state, a state of perfect equilibrium, cold, dark, and uniform, a state of ultimate profound rest. The great cosmic story will be over, the lights will have gone out, and all that will remain is silence. There is a strange and deep peace in this thought, a universe where everything is finally done, a canvas on which all the brush strokes have long since dried. The silence isn't frightening, it is restful, it is complete. And so, we return from our quiet journey across time and gravity. We have drifted through the long lives of the sleeping giants, from their fiery births to their impossibly distant silent ends. We have seen that they are not agents of chaos, but architects of cosmic order, guardians of stillness. And now, as your own eyes grow heavier and your breath slows to the rhythm of a drifting galaxy, perhaps you have found a small piece of that cosmic peace in their story. The universe, it turns out, has its quiet places too, and you have found one, here, now, in your own comfortable space. If this slow voyage through time has brought you comfort tonight, perhaps you might leave a quiet sign of your passing, a gentle like, a soft subscription. These small ripples of encouragement help our little ship reach others who are seeking a harbor of stillness in the vast night, but only if you feel so moved. Your rest is the most important thing, and if you are already asleep, that is wonderful. That is why we are here. The story has done its work. Until our next journey, dear traveler, sleep softly, dream deeply, and let the quiet sleeping giants of the cosmos watch over you in the silent, starry, and peaceful dark.